This is work example for geometric distribution. The first example, which is question 1, the student throw the darts 4 times and the probability of success for student to hit the red mark is 76%. The probability of success is 70%, which is P equal to 0.7. P equal to probability of success. This is called the random variable. At bigger S equal to 4, which is 4 times. And then we substitute this data into this formula, which is 1 in bracket 1 minus P close bracket the power of R minus 1 multiplied by bigger P, which is probability of success. And then we substitute this formula from this data. And then we can see 1 minus 0.7, the power of 4 minus 1 multiply 0.7 equal to 0.3, the power of 3 multiply 0.7, and then the answer is 0.0189. Meanwhile, the question 2 is the student throw the dart 11 times and the probability of success for student to hit the red mark is 70%, which is, let's say the random variable x bigger x is equal to 11, px equal to 11, and then we substitute the data same as above, 1 minus p, and then we solve the solution. It become 0.3, the power of 10 multiply 0.7, and then the result which is very small, which is 0, 0 and 0.95 and 4133343, or equal to 4.133343 multiplied by then 10 the power of negative 6. It's very small, the probability of success. And then the question 3 is the student throw the dart less than 6 times and the probability of success for student to hit the red mark is 70%, which is P random variable or bigger S less than 6. We must search the data below than 6, 1 until 5. The 1 is 0.7, and then the 2 is, we just substitute the data into this formula. The 0.3, the power of 1 multiply 0.7 equal to 0.21, and the third one is 0.3, the power of 2 multiply 0.7 equal to 0.063, and the fourth one is 0.3, power of 3 multiply 0.7, which is 0.0189, and the fifth one is 0.3, the power of 4 multiply 0.7, which is 0.00567, and then the result is we get the total of this answer is 0.009 0.99757, which is equal to 99.757% of the probability of success that the student we got. And then the question 4 is the student throw the dart more or equal than 7 times and the probability of success for student to hit the red mark is 70%. We must search the answer 7 and above or equal to 7, which is we take only 4 because 7 into infinity we cannot take infinity, we just take 4 after 7, which is 7, 8, 9, 10. We substitute the data same with as above, which is 0.3, the power of 6 multiply 0.7 equal to 0.0005103, and the 8th one is equal to 0.3, the power of 7 multiply 0.7, which is equal to 0.0001539, and the 9, 0.3, the power of 8 multiply 0.7 equal to the 0.000054927, and the 10th one is 0.3, the power of 9 multiply 0.7, 0.00013 7781. And then after we get all the data here, we substitute the formula S infinity, because we cannot search until infinity. We're going to use this formula, which is S infinity equal to A over y minus r. A equal to the first number that we search, which is 0.3, the power of 6 multiply 0.7, which is this answer. We take this and then 1 minus 0.3. R is the common ratio. The common ratio that we get, the first number that we multiply into this, which is 0.3, 0.3, 0.3. This is the first number. This is common ratio. And then we got the answer, which is 0.000729, which is, then after that we add the two number, which is p s greater or less than or greater or equal to 7, which is 0.002729, and then p s less than c, which is 0.99, 7.7, which is, we must plus this the answer, which is to cover everything, which is the answer must equal to 1, not less or more than 1.0000. And then if the answer is correct, you are right. Okay, this is our second work example for geometric distribution. Let's say the question is, on the first production of line, a gift is placed in a Waverly Fork pack of crease, and then calculate the probability of first getting a gift after buying. The part A is exactly 4 packets, B at most 2 packets, C at least 7 packets, D at most 10 packets. This is the formula for geometry, which is S is equal to random variable equal to the geometric distribution. And then this is formula for the geometric distribution, which is P S equal to small r equal to Q the power of r minus 1 multiplied by P. And then this one for the infinity formula, which is P bigger S greater than r small equal to Q the power of r, where Q equal to 1 minus P. Let's solve this question. Let S be the number of packets bought to get a gift, where S equal to geometric distribution, which is 0.5, 0.25, not that 1/4 of chip. And then this also state as a P. This one P. And then we say the section A is exactly 4 packets, which is P S equal than 4, which is exactly equal or refer to equal, S equal to 4. And then we solve the equation as the formula refer above. And then Q equal to 1 minus P. And then we substitute the formula equal this into this method, which is P S equal R small equal to Q R minus 1 multiplied by P. And then the Q we get here is 1 minus P, which is this the formula, which is 1 minus 0.25, which is 0.75 in bracket 3 in bracket the power of 3. 4 r is equal to 4. 4 minus 1 equal to 3. And then this bracket 0.25, which is P equal to P. 0.25 is P. And then we solve this formula, the answer is 0.105, which is 3 decimal point. We take 3 decimal point. And then meanwhile for the part B, at most 2 packet, which is P less than or equal than 2. Equal to P, we must plus PS equal to 1, because less than 2, plus PS less than P equal P bracket S equal to 2, which is p less than 2 or equal to 2. And then we take the data here. If s equal to 1, just straight away take the p 0.25 plus 0.25 multiply 0.75, which is we get from here p 1 minus p, which is 1 minus 0.25, it become 0.75, and then the answer is 0.4375. Meanwhile, for the question C is at this 7 packets, which is p greater than or equal to 7, which is ps greater than 6, which is greater than or equal to 7 is 7 into infinity. We cannot search, and then we substitute using the formula. If involved in the infinity, we substitute with this formula, which is ps greater than r small equal to q the power of r, which is we just substitute here. Q is 0.75 close, and then greater than 7 or less than 7, greater or equal to 7, which is 6. We get 0, 1, 0, 1, 2, 5, 4, 6, 7, 6. This is we equal to this. R we get 7 minus 1, which is 6. We substitute the formula like this. R is 7 minus 1, which is 6, and then we solve this formula, we become this 0.178, which is 3 decimal point. And the last part is s less than 0 or equal to, ps less or equal than 10, which is the solution is 1 minus ps greater than 0, and then 1 minus 0.75, which is this, we get here p 0.25, 1 minus 0.25, which is 0.75, the power of 10, and the answer is 0.944. We take only 3 decimal point, which 3 as f equal to 3 decimal point. That's all for us. Thank you.
Assalamu alaikum warahmatullahi wabarakatuh. Now I will give exercise about geometric distribution. The exercise says, when two fair dice are rolled, the probability of doubles is 1 over 6. Let x be the number of times two fair dice are rolled until doubles show. Find the probability of x equal to 1 and probability of x greater than 1 and the expected value of x. To solve this question, we see the random variable x distributed with geometric distribution. Then the function of f of x equal to p times 1 minus p over x minus 1. Because we try the experiment to get the first axis until double show. Then we have the function and the probability. It's p equal to 1 over 6. Then I will substitute when p of x equal to 1, probability of x equal to 1 equal to f of 1. Then I substitute by the probability and the value of x. Then 1 over 6 times 1 minus 1 over 6 power 1 minus 1 equal to 1 over 6 times 1 minus 1 over 6 power 0, then equal to 1 over 6. When x greater than 1, the probability of x greater than 1 equal to 1 minus probability of x equal to 1, because the x greater than 1. That means x take the values from 2, 3, 4 to infinity, but not get the value of 1. So we know the summation of all the probability of x from 1 to infinity equal to 1. Then the probability of x greater than 1 equal to 1 minus probability of x equal to 1. Then equal to 1 minus 1 over 6, because we get the probability of x equal to 1 equal to 1 over 6. Then the probability of x greater than 1 equal to 6 minus 1 over 6 equal to 5 over 6. The expected by the properties of geometric distribution, the expected equal to 1 over p. We have the value of p equal to 1 over 6, then the expected of x equal to 1 over p equal to 1 over 6 equal to 6.